Good morning. We're learning chapter 5 this week. So I want to show at least one example on the homework. So I assigned the homework for chapter 5, and 5.5 is mixing the method that we mentioned in the chapter. So I posted a solution just in case you want to know. I posted a solution for the first work, the first question in 5.5 for the mixed method. And it's so it's when you try to save money to move to a different place. So this is the background story. The new cash flow, which is 13,000 per year, is what you're hoping for. So you have to save money to have that cash flow of 13,000 per year, which you were expecting for this cash flow to last for 10 years. So at the year 2015, you should have already have your money saved up. And so in the years leading to 2015, you have to save money. And we're trying to figure out how much money should you save each year. And we're assuming this is a Q in my graph. So I'm drawing the timeline and try to identify the cash flow. So this money has to equal to the money required for the cash flow that we needed in the new location. So the 13,000 times 810 is how you calculate the present value, which is 2015 value of the cash flow in the following year. That can be calculated. I didn't exactly calculate it. I just want to combine them into an equation. So in 2015, it says that we got to make deposits since 2000. So we have 2000, 2001, 2002, until 2015. If you count the total number of payments, if 2000 also have a payment of $Q, then the total number of payment is actually 16. See, at first I thought it was 15 because 2015 minus 2000 is 15, but you have to count the first payment. So the total number payment is actually 16. So then we are calculating a future value for annuity immediate. So this 2015 value of the 16 payment, the value of the not 16 deposits, not 10 deposit, is 16 deposit, not 10, 16. So it's a future value, so we use S. So that's what coming out with a green formula, the 13,000 times A10 equal to Q times S16. With that, using the formula for A and for S, we're able to calculate Q. That's pretty much how you solve question 1. For the second question, it involved trying to compare, understand the differences between amortization and thinking fund method. This is two different methods. Now, the amortization is you're paying the principal and the interest at the same time. So for each payment following a previous payment, you always figure out how much interest that should be interest is a cost that we pay for the cash flow. So interest has to be paid first. Then whatever left in that payment should be counted paying for reducing the principal. That's amortization. Now, sinking fund method is what if we wait to pay for the principal and we pay the interest first. So always make sure the interest for each time period is paid first. Um, that's the idea. And so then we can pay the the principal as a lump sum payment by the end of the time period. The end, you can also call that expiration of the loan. Um, so this calculation saying that we should compare the two payment method, and you can see both of the sinking fund method and amortization, we have to count both the reduction of principal and the payment for the interest. So we actually do both. So what's the difference? The difference is in the sinking fund method, you have to set a separate account, which is called a sinking fund account. In that account, the interest, the accumulation money is being combined using a different interest rate. And that's what's causing the difference between amortization and sinking fund. If your sinking fund account is using the same interest and same convertible, same interest format, then sinking fund and amortization would have the same value or same type of payment if the payment period is the same. So they would be very like they'll be identical. Sinking fund amortization, they could be they exactly the same if the interest rate and interest period are identical. The differences is caused by the interest. So you can see that if you are paying using the amortization, then you're paying. We're assuming we're making, let's say, assume monthly payment and monthly deposit for the sinking and monthly payment for the loan, and we're paying a certain amount each month to pay off the loan, and then so assuming that's we're gonna pay it off in 18 years. Okay, so for the amortization, your interest rate is 8.9% convertible monthly. So your monthly interest is 0.089 divided by 12. But for the sinking fund, your interest, you have to pay off the interest to your original loan. So the interest payment should be the same interest. You're paying 8.089 divided by 12 times the principal each month, and that's the the amount of interest you have to pay. Since in the sinking fund method, we are waiting to the end to pay the principal. So the principal is actually the same the whole time. So your monthly payment of the interest would be the same. All right, and then you're gonna have to set up a separate account, try to save up the money to pay off the principal in the end. And so the separate account, that's the one that we have to so the sinking fund deposit is 7.2%, and that's the account that we're saving up to have enough fund to pay for the principal. So that's the thing. So then let's look at the calculation. I just want to explain this one so you kind of see a comparison between the two methods. And so I'm going to explain the solution here. Um, so here we are. Okay, so we're gonna first calculate what's the amortization. Using the amortization method, what was the amount of payment? And this is more familiar because let's assume that you are paying a monthly payment, because it says here that we were supposed to make monthly payment to pay off the loan. And we're paying off in 18 years. So how many payment do we get total? It's 18 times 12. And that means that we are paying 2016. That's the end. That's the number of payment. So that's how many months it is. So start with time 0. And then we have time 1, time 2. And how many payment do we get? 2016 number payment. And each payment is our monthly payment. Let's call that Q. And assuming that we're paying the same amount, see, that looks like an annuity immediate that we're calculating. So the monthly payment end up being this. So Q times A, we have A 216, and the interest is going to be the 0.089 we got to turn that into a monthly. This is convertible. It's convertible monthly. So then the interest is being divided by 12. That's making a monthly interest because we are making a monthly payment. So using this calculation, you can say Q is equal to, this is supposed to equal to the total loan amount. And the loan amount is 18800. So Q ended up being a division. So we have 188. This is something we have already done in chapter 3 or 4. So this is combining the previous method and previous formula that we learned. So this is divided by A. So divided by A 2016. And this is supposed to be, let's call that I. And I should be the 0.089 divided by 12. And that, if you calculate it, your answer should be the 1748.79. So that's the amortization method. This Q amount involve reduction of interest first, and then the rest is amortization. For this payment amount, you don't have to do the amortization schedule or the table because we're trying to consider having a equal monthly payment. It says how much will he save each month. So it looks like we're making a plan to pay the same amount each month. And let's move on to the second method. Then what if we're paying it with the sinking fund method? For the sinking fund method, then you're looking at two different timeline. The first timeline, you're trying to, we have to make sure, guarantee that every month the interest is being paid off. Now, how much interest are we paying? Since in the sinking fund method, we do not pay the principal until time n. So your principal stay, you pay this in the end. You pay this much in the end, but every month you're gonna pay the monthly interest. What is the monthly interest? It is 0. It's 0. This is called the interest pay. Call that. All right. So this is multiplied by 0.89 divided by 12 because every year we're supposed to pay 0.89%. And each month, this is convertible monthly, so each month we're paying 0.89 divided by 12. So you're gonna find out the interest here, and it ended up being a value of 1394.33. So if you don't pay the principal at all, the whole time period from 0 to n, then every month you have to pay this much interest. And that's the thing, some people will mention that we have to pay a little bit of the principal because your principal affect how much interest you're paying. If you don't pay the interest at all, you don't pay the principal at all, the principal stay there which is really large. And that means every month you have to pay a whole lot. All right. But then what about the principal? Well, we are saving it. The principal is 18800, and we're saving up enough money to make sure. So this is the interest pay. We actually pay this much every month. Now for the um, principal, we're saving in a different account. So over here, it's mentioned that we're depositing money into a sinking fund to save up the money to pay for the principal. And the account we're using actually have a lower interest rate, which is no good. And that's kind of indicated that when you're, if this one's, I suspect if this one has a higher interest rate than the 8.9, we might end up paying less because that allows your money increase faster to the 18800. So then your money grows faster, and that means you don't have to save that much money each month. But right now that interest is low, that means your money is not growing as fast, and that means you have to invest more to achieve a certain growth of money. So anyway, this is kind of the reason that for this example, the amortization is better than the sinking fund method, because the sinking fund method ended up having a higher monthly payment. That is the interest payment and the principal payment combined. All right, let's look at the principal. So for the paying for the principal, we're paying a certain amount each month, and that's called that M. So we have M here, M here. We're saving $M per month into a account with a 7.2% account. All right, and then until 2016, we're still paying M. So in this case, we're saving $M per month times the A to 16. This time the interest is 0.072 over 12. And this is supposed to equal to the 18800. Okay, and then this M, you will calculate it using the, well, what was 18800 divided by A to 16 with interest rate of 0.072 over 12, a different interest rate. Now this is causing a monthly payment of, oh yeah, we're saving money for the final amount. I guess I was using the wrong symbol. It should be the future value, not the present value. Should be a S to 16. Not the A to 16. A to 16 is the present value, and this is S to 16. So we're saving the money, and to make sure in the end, by the time 216, we will have sufficient fund. So S obviously is higher than the A. So this division gives us a small number because the denominator is bigger. So this number ended up being 427.19. You can double check with your calculator using the formula. So you can see with this one, the total monthly payment ended up being, so you're gonna add this one with this one, and that ended up being higher than the 1748. They're very close, but definitely higher. So we added the blue calculation together minus the orange calculation. That tells you how much better the amortization method compared to the sinking fund method. This is how much you're going to pay for the sinking fund method. You save this much to save up the principal, and this is how much interest you have to pay per month. So I hope that kind of explained the sinking fund method in comparison with amortization method. Basically what we're doing in chapter 4 and 3 are mostly amortization, or at least the interest is not different. Now, as far as the sinking fund method, if this account they were saving up having the same interest rate as the original loan amount, loan interest, then it would not make a difference. So most of the time I would prefer looking for, if you're saving money, and we definitely hope for a higher interest rate. If the interest rate is lower than the loan amount, I don't see the reason to have the sinking fund method applied. If you have any question, please let me know. All right. So when you try to borrow money, you certainly are hoping for a lower interest rate, but if you're saving up money, you are hoping for a higher interest rate.